this work almost is similar to the previous speaker, but the only thing is this is not a coastal area. It is a area which is well within the, it's a midlands. So then we have other issues instead of salination. So basically we are interested in the assessment of the groundwater quality, especially for the suitability for irrigation and drinking purposes. What is happening is many people are using it without considering it the pollution levels, and later causing a lot of problems in terms of health hazard and other things. So this assessment has become very important. So if you see the my presentation, I have divided into basically introduction, study area, methodology, and then I will give some results and discussion and conclusions. So as told by my speaker, in my country especially, the groundwater is a very important source of water, especially for irrigation and drinking purposes, as the rainfall is scanty at many places and we do not have sufficient sources. And this groundwater has in fact impacted our economy, and it's an important catalyst for the socio-economical development. Because of its low cost, it's the most preferred source of water in India. It is as important as a precious natural resource. Can give them 85% of the population use only groundwater for their normal drinking and irrigation purposes. So my friend just discussed about coastal aquifers, the sea water and all that. But I will be discussing about water which is not in the near the sea, which is inside the midlands. There the stress on groundwater, both in terms of quality and quantity, is increasing rapidly because of the change in the pattern, land use pattern, other things. The problem we have is of industrial effluents polluting the groundwater. So there is a need to assess the groundwater quality, and especially as industrial effluents and unsustainable agriculture practices are taking place. So I will be mostly discussing about the work that we have carried out jointly. This is a joint paper with my colleague. So basically I have taken a district. This is a drought prone area in the city of India, and this is located between 12 degrees 37 minutes and 14 degrees north latitude and 78 degrees and 79 degrees 55 eastern longitudes. So this particular district receives very moderate rainfall, and most of the years failure of monsoons is there, and this has led to extensive usage of the groundwater. And the soils of the districts are basically red loamy soils, red sandy soils, and very few area, about 9%, is concerned with black cotton soil and other things suitable for agriculture purposes. So if you study the rainfall pattern, you will find that the annual rainfall is only 943 mm, which is varying again from 600 mm to 1280 mm in the whole district. So this district actually experiences 60% more below than the normal, so which is a very cause of concern, and very few districts have got rainfall above normal. So on average, the district rainfall was deficient by 61% of them. This study had to be carried out before actually assessing the usage. So the Chittoor district is absolutely dependent on groundwater for its irrigation. There is no other source of water, there is no other source of irrigation. So only the groundwater is required for drinking as well as for irrigation needs. So out of this, the total irrigated land, 84.34% is irrigated through dug wells, open wells, and about 19,849 for shallow bore wells, and about 28,933 by deep bore wells. It all depends on the capacity of the farmer, what type of water source he wants. So, once you have a bore well, you require diesel engines and electricity. So another expenditure is there. So almost the drinking and domestic requirements of about 10,000 habitations are met through 6,200 PWS and MPW schemes, and about 20,368 bore wells. So this is the thing. So the overall stage of groundwater development of the district is about 72%, and it is characterized semi-critical. and there are as many as 781 villages which are declared as overexploited. That means there is extra exploitation of the groundwater which is leading to depletion of the levels, and as there are no existing major irrigation projects, this is a cause of concern to the surrounding. If you see this map, it shows clearly that majority of the districts is having a very scant rainfall. In fact, there are no irrigation projects except very few locations, but these also do not have sufficient water, and the majority of the thing is uncovered with other things. The water resources is only about 450 MCM. The groundwater, out of this, the groundwater utilization is 1030, and only the balance is from irrigation projects that they want. So the stage of groundwater development arrived at is about 72%, and the district falls in the semi-critical categories. So based on the stage of developments, about 18 mandals are overexploited in terms of the groundwater and other things. These are some of the areas of the districts where a study has been made. And if you see here, in fact, very few areas have got safe, but this red shows the overexploitation of the thing, and which has led to depletion and also the pollution of the groundwater. So we have taken the overexploited area and tried to study how the water quality is changing. So the quality of groundwater has been studied mostly by collecting water samples from the villages. These are the few villages, the names, Penuru, like that. And we have taken a random of 20 samples, and we have collected 19 samples from bore wells and 1 from open dug well. So these samples again were being tested for the quality in terms of the pollutant levels like pH, EC, TH, DO, sodium, potassium, and alkalinity. In seawater we had the acidity problem, but in groundwater away from the sea we have the problem of alkalinity, which is again not good for the irrigation as well as drinking purposes. So there was an assessment need to assess, because the farmers are uneducated and there is people are using it totally without any scientific basis, and getting into laws and loans, committing suicides because of the loss in the crop and all that. So a study was carried out to see how suitable water is for a drinking purpose. So this is the district, whole district, and we have taken a small area here to make the study. And the methodology that we have done is, we have taken first the collection of the hydrology from the wells, we have taken the rainfall data, we have collection of water samples, and then we have analyzed the water samples for all the chemicals, and these were the results. The results said that the drinking water standards of WHO and Bureau of National Standards was the basis of groundwater quality for drinking purposes. And then we carried out the chemical analysis of the samples for the following parameters: DO, pH, TH, EC, sodium, K, and alkalinity as given in table 1. So this is how the different parameters are there, and in most cases they were beyond the, if you see here, this is the rainfall, and this is how the normal deviation of normal. So there is a shortage of almost 20% in the year 1999. Recently in 2005 it is a 24% shortage. So as the time is going on, the rainfall is getting lower and lower, and people have to depend more and more on the groundwater. So there is an important need to assess how good is the groundwater, especially with the parameters like dissolved oxygens, and then pH value. We have seen that most of the thing is alkaline, and but luckily it is not very varying, so it is within the permissible limit. Hardness again is a very important thing. So water is very hard, and because of this, there is a problem in terms of drinking as well as for using for domestic purposes. The electrical conductivity is also quite high. The sodium is also more than the permissible value. So these are based on the study that we have found. The potassium levels, the alkalinity is quite high, and this is again not a good sign. So based on this study, we have concluded that the chemistry of the groundwater in the area, especially Midland area, is an important cause of concern, especially with respect to sodium and potassium levels, causing again the health hazards and all that. And we have seen that the pH value is very high. That means showing the alkalinity nature of water. The total hardness and alkalinity are more than the permissible limit. So therefore, the water is not good for industrial purposes. As it is hard, it cannot be used for domestic purposes, as there is no considerable health effect due to hardness. Only it can be used for domestic purposes because alkalinity water can be used, but still exists a health hazard. And we found that other parameters like alkalinity and other things are affecting the health as well as the irrigation capability of the water. So here, again, these are the values that we have found based on our analysis in that area. Is a typical study area. And most importantly, because of the depreciation in the monsoon, it is leading to less discharge of groundwater and more draft from the groundwater reservoir. As a result, every year the water levels are going down, and in some cases, most of the wells are getting dried. And again, there is a need for re-digging all this. So this necessitates construction of additional bore wells to provide water to the standing crop. More often, the new bores are likely to be a failure because of absence of desaturation aquifers. In the over-exploited areas, large-scale artificial discharge of groundwater has to be taken up, like the rainwater harvesting, which was discussed earlier. And also, not only that, we have to have a regular maintenance of these structures, which is often not done, and some budget should be provided. And most important is mass awareness to educate the farmers regarding the groundwater management, especially in terms of its pollution levels and for using for irrigation as well as for industrial purposes. And training using scientific techniques to the local farmers is a must. So thank you very much. Thank you for giving this support. Thank you.
Thank you, Professor. We have any questions from the group? Here's one.
What is the geology of the area under study? Because that will help us to understand
soil.
The geology.
The geology, the soil is basically, I just showed you that it consists of basically different types of soils, but majority of the soil is red soil. So its pervious levels is very, I'll just show you 1 minute. Yeah, the soil is 57% is red loamy soil.
No, I'm talking about the geology, the formation, the geological formation.
Okay, the formation as the rocks are there.
Yes.
You have faults. So normally rocks are available at a level of more than 10 to 15 meters. And these are sedimentary types of rocks.
Okay, because looking at the property, it seems that you're likely to have things like limestone or shale under, because with the nature of the characteristics of the soil and the water. The area seems to be underlain by shale or limestone.
Exactly.
Okay, because that will greatly impact on the quality of the underground water.
Yeah, that is affecting the quality of the underground water, especially the pollutant levels. Like alkalinity, I said, the alkalinity levels are getting higher.
Yes.
And it is therefore not suitable, and the hardness is more, so it's not suitable for industrial purposes.
Yeah. And also even domestic, that means you have to spend more on soap.
Yeah, especially hardness, it doesn't help in cleaning and all that. Yeah.
Yes.
Thank you.
Any other questions? If not, thank you, Professor Rao.
Thank you.